All right, so I was going to first, before we get into the normal distributions lesson, so you can skip ahead to that if you are interested in watching the normal distributions lesson only. I was going to do like number 1 on Friday's pull together for uniform distributions. So it says the radii of pizzas at Papa's Pizza are evenly distributed with a mean of 10 and a range of 12. And it says draw a picture of this distribution. So hopefully from Thursday, you remember you're just going to put 10 in the middle. That's the mean. And the total range, the distance across on this evenly distributed distribution is 12 inches. So I'm going to go 6 to the right and 6 to the left for a total of 12. So that's our distribution for this radii of pizzas. Then it says, what's the probability that a randomly selected pizza has a radius greater than 11? So I want to know what's the probability x is greater than 11. And this is where x is the radii of Papa's Pizza. I think I forgot an apostrophe there. So we probably need to find the height before I can find probability. Remember that the area is 100%, and that has to equal base times height. Our base is 12, so the height has to be 1/12. And I think we have to shade quite a few of them, so I'm actually going to avoid shading on here, but we need to go from 11 to 16, which is a distance of 5. Actually, I'll show the first one. So 11 to 16, which is a distance on the base of 5 with a height of 1/12. So base times height is how we find the probability here. Nothing too difficult, and that gives us 5 times 1/12, which is 0.417. The next one is less than 8 inches. So that'd be going from 8 down to 4, which is a distance of 4. So 4 times 1/12, which I believe is 0.333. Repeating. Between 9 and 11 is 2 inches. So the base between 9 and 11 would be 2 times the height of that distribution, 1/12. So that leaves us with a 1/6, and I don't know what that is in terms of decimals. 0.167. These are pretty quick, to be totally honest. There's not much to them. They're just, areas of rectangles. It says, what do 1/4 of all pizzas have a radii less than? So what we could do here is we know that the probability is 1/4. So I'm going to say 1/4 is equal to base times a height of 1/12. This is where I would start off. The probability of getting it is 1/4. We want to figure out what that base width is, and we know the height is 1/12. Algebraically, to solve in this situation, what I'm going to do is multiply both sides by 12. And so we end up getting the b has to be 3. So we want to find some value where from there down has 1/4 of the probability. So it's just going to be 3 away from the bottom. So 7. This little green rectangle right here would have 1/4 of the total area. So 7, I think these are inches. Yeah, inches. All right, and I think the next one's kind of the same thing. Hopefully that helped you out. There's also questions that have stuff about the mean and standard deviation, just in case you forgot them. When it comes to evenly distributed distributions, the mean is just going to be b plus a or a plus b over 2. And the standard deviation is going to be the square root of b minus a squared over 12. For a question that asked for that when it comes to uniform distributions. Now we're about to switch gears to normal distributions. So all of this reasoning is not applicable to normal distributions. So it's really important you recognize these formulas, and this like rectangular stuff only works when you have even or uniform distributions. even or uniform. That's all this stuff is good for uniform or even distributions. All right, so let's get on into the lesson part. I want to scroll. It's probably a faster way of doing this. Okay, so on to normal distributions. These are going to be a very big, important part of the rest of the year. We'll be doing a lot of stuff with these normal distributions. So it's pretty important you get a nice base for what we're talking about here. So these are symmetrical bell-shaped unimodal. That means they have a single mode density curves. They're above the horizontal axis, of course, because all density curves have to be above the horizontal axis. This is a way of denoting a normal curve. This is going to be seen quite often. You might want to make a note of this. This just means it's a normal distribution. That's what the N stands for. Mu tells you where it's centered, and sigma tells you what the standard deviation is. So this just describes a normal distribution. The transition points, the stuff where your curve goes from down like a frown to up like a cup, is going to be from mu plus or minus sigma, and I'll show you what I mean by that in a second. This can be called points of inflection if you've taken calculus. Probability is going to be calculated by finding the area under the curve. And the way we do this mathematically would be using calculus, using integral math, which we do not know or expect you to know in this class. So it's going to be primarily done through the power of your calculator. Ooh. And this is a fact we've hopefully known, which is as your standard deviation, sigma, increases, the curve gets flatter and spread out. If your deviation's larger, that just means that everybody's kind of further away from average. So everything kind of gets spread out. So here would be the example. If the original curve looks like this, and you increase your standard deviation, you get a flatter curve. That's also pretty important to be aware of. It'll come up oftentimes. This, by the way, is what a normal curve looks like. This is also a normal curve. It's just a flatter normal curve. As sigma decreases, so your standard deviation goes down, that means everybody's getting closer together, so your curve gets taller and skinnier, so it looks like this. This would be a low standard deviation. Because deviation is how much everybody's going away from the average, so if you have very low deviation, everybody's really close to the average. It's very tall and skinny. Okay, so a lot of things have normal distributions. Anything that's like naturally occurring, especially like heights of men, heights of women, the number of petals on a rose, those tend to be normally distributed. Anything that's like naturally occurring, if there's like a bunch of different roses, then the distribution of rose petals would be normal. Here are some examples. The length of a newborn child, the height, the weight, ACT or SAT scores, they're intentionally normally distributed. Intelligence, IQ, is on a normal distribution. Number of typing errors, if you, over many attempts, type a bunch of papers, the number of errors you make would be normally distributed. I don't know what it means by chemical processes, but I trust it. That makes sense. Okay, so here are two different normal curves. We have curve A, curve B. The first question is, do these two normal curves have the same mean? Now, hopefully you recognize, yeah, they have to have the same mean because they're centered in the same spot. These definitely have the same average, the same mean. And it says, if so, what is it? Assuming these are going up by 1, this would be 1, 2, 3, 4, 5, 6. So the average would be at 6. And then it's asking us these two questions, and I think it's best to kind of look at them at the same time. It says, which normal curve has a standard deviation of 3, which is a very high deviation, and which normal curve has a standard deviation of 1, which is a pretty low deviation? Remember, the lower your deviation, the taller and skinnier your graph has to be. Why? Because there's not much deviation from the average. Everybody's pretty close to average when you have a standard deviation of 1. So hopefully with these two facts, you should be able to recognize it. Oh, well, the tall, skinny one, A, has to have a deviation of 1, and the flatter one has to have a deviation of 3. And this is something called the empirical rule, which I think we've already used in the past. And that told us that most of your distribution should be within 3 deviations of the average. So if you look at this tall, skinny curve, and you go over 1, 2, 3, so the deviations of 1, you have most of your curve. Most of your distribution has to happen within 3 deviations. B, you can see right here, it still has some room to grow off to the side, so it's still not quite done with this curve. This is the empirical rule. I'm 99% sure we've already talked about it and used it in this class, although AP statistics and on-level statistics kind of blends together for me, so I have functionally no idea if we've done this before, but I'm like pretty sure. And if not, this is the empirical rule. It's worth writing down. No, we definitely have done this. And so approximately 68% of observations have to fall within 1 sigma of the average. Approximately 95% have to fall within 2 sigma of the average. And approximately 99.7% fall within 3. This is definitely worth writing down if you have not memorized this from the past. I'll pause for a second so you can write down the empirical rule. We're going to kind of venture away from using it very often, but it does come up every now and then, so it is worth writing down. The main takeaway is a large portion of people are within 1 deviation of average. Like you're gonna have a lot of people, the vast majority really, like 70% are within 1 deviation of the mean. And then almost everybody, if you consider every possible person, they'll be within 3 deviations of the mean, 99.7%. Even your really, if you're talking about heights, even your really, really tall people are usually within 3 deviations of the average. Okay, so here's a setup. The height of male students at Plano Senior High School is approximately normally distributed. This is something you want to get into the habit of noticing on problems, this unit. Does it say it's uniform? Does it say it's normal? What kind of distribution am I working with right now? So this is a normal distribution with a mean of 71 inches and a standard deviation of 2.5 inches. So this is all we need to describe our curve. It's normal, centered here with this deviation. Step 1 would be draw and label the normal curve. It helps because we're going to shade it later on. It helps us visualize where probability is occurring. So in this case, this is what the normal curve looks like. The points of inflection, as I stated earlier, are right here. So when you go from down like a frown to going upward parabola kind of looking shape right here. The middle is going to be mu, which in this case is 71. And then the standard deviations are each 2.5 inches away. This is a fun little graphic we got going on here. So the middle 71, if you go to the right 2.5 inches, that's your first deviation away from average, second deviation away from the average, third away from the average. Or if you go backwards by 2.5, same thing. And then this is just something we learned in the past, which is the middle is that 68%. This is just the empirical rule. Between 68.5 and 73.5 will be approximately 68% of the people. This 13.5 and that 13.5 happens because this total area is 95% within 2 deviations. They just did some simple math to figure out this was 13.5 and 13.5. And then this last deviation is 99.7%. So this is almost everybody, and that's how they find these 2 little pieces. You're welcome to write these down. These can be useful, these little area breakdowns. I think your note sheet has a place for it if you're taking notes in it. You can pause here for a second. All right. Oh, and then the remaining area. Forgot to click one more. And then you might be asked a question like this using the empirical rule. What percent of the male students are shorter than 66 inches? So you'd find 66 inches right here. And then you could just add these two areas together, and it turns out approximately 2.5%. 2.5% of students are less than 66 inches, or male students. Nothing super difficult, to be totally honest. You just have to read this graphic and kind of find those areas. Again, these numbers are probably worth writing down, especially because you can use your notes on your quizzes and tests. I mean, there's like no downside to taking these as notes for these empirical rule questions. And the PowerPoint's available on the Google Classroom, so you can always, if you need to, go back to the slide. The next question says, what percent of the male students are between 66 and 73.5? So I'm going to just find 66, and then I'm going to find 73.5, and I'm going to add these three numbers up that are in that region. So 13.5% plus this 68 in the middle. I think it's 81.5. Yeah. Nothing scary. It's fine. What percent of the male students are shorter than 76 inches? Why don't you guys try this one for a split second? At least try and think of what you would add to find that. Hopefully you decide to add all of these numbers up till 76. You could also do 1 minus these two numbers, which are 2.5. That might be faster. Either way, we would get 97.5%. Taller than 68.5. Hopefully you get the gist by now. You just add these numbers up, and you get approximately 84%. Percent of the male students that are between 68.5 and 78.5. And so I think these are pretty repetitive. If you wrote down these numbers, hopefully you can add in your calculator 34% plus 34% plus 13.5% plus 2.35%. Nothing super critical. Okay, and then we start getting into these percentile questions, which say approximately 84% of the students are shorter than what height? So we want to find a height such that 84% is below it. One way you could do this is you could just keep adding these numbers until you eventually get to 84%. And so apparently it happens right here. So 0.15% plus 2.35% plus 13.5 plus 34 plus 34 adds up to be 84%. So 84% are less than the 73.5. Let's keep going with these. Approximately 97.5% of the students are taller than what height? So this time we want to find a very short person. So what we do is start on the right end. So we want to find a short person where 97.5% of people are taller than them. So we're just going to start adding from the right all the way over until we eventually get to 97.5, which happens here at 66. Cool. Okay, tomorrow we'll start talking about how your calculator can do a lot of this stuff, but for today, we're going to base most of our math off of this little curve right there. Maybe I'll do, I don't know, a homework problem or two, just to make sure you're okay with this stuff. So let's look at today's worksheet. It says the normal distributions and empirical rule worksheet. What you can do is, it says, fill in the curve with the appropriate percentages. This is very small handwriting, so I'm going to try my best to fill this in. So this is 34%, 34%. Maybe I'll just use arrows, that's probably better. I believe these are 13.5%. These are 2.35%. And these should be 0.15%, I believe. Let me just make sure that's right. Yeah, 0.15%. Awesome. And then it gives us a setup in this situation where the heights of college women are normally distributed. It's important to be paying attention to what the distribution is. This one's obviously normal. And then the mean is 65 inches, standard deviation 2.5 inches. So this is 65 in the middle. And what we could do is we could just find the rest of these by adding or subtracting 2.5. You can use Dora to help you out with that. Calculate with Dora. So 65 plus 2.5 would be 67.5. Do that again, plus 2.5 would be 70. Maybe you don't even need Dora. And then you do it again, that'd be 72.5. And then going the other direction, and I really wish I could write smaller, but we're just going to do 65 minus 2.5, which is 62.5. Minus 2.5 again, 60, and then minus 2.5 again, 57.5. Basically, you're doing all the front load right now, like all the work is being done drawing this graphic, and then we can just answer all of these questions pretty quickly. So X is going to be the height of college women. And want to know what's the probability that a person or a college woman is taller than 65 inches. So X is greater than 65. Well, this one's pretty easy because the mean is 65. It's in the very middle of this symmetric curve. So this has to be 50%. That's the only answer that makes any sense. You could also add these probabilities up. You'll get 50%. Next, it says, what percentage of women are shorter than 62.5? So what I'm going to do is find 62.5, which is right here. I can just add these percentages together. So that's going to be, what is that, 2.5 plus 13.5. So that's 16%, I believe. Let me just make sure with Dora. So 0.15 plus 2.35, nope, 0.235. That should be 0.0. If you're going to do decimals here, this is my mistake. It should be 0.0015 plus 0.0235 plus 0.135. Because remember, if you're doing percentages, you have to move the decimal over twice for the decimal. So we get 16%. You could also do it as their percentages. So you could put 0.15 plus 2.35 plus 13.5. You could keep them as percentages and get 16%. It's up to you. The answer is going to be 0.16 or 16%. They're equivalent to each other. You can write it either way. On the quizzes and the tests on my math lab, though, pay attention to if it wants a decimal percentage or a percentage. For C, it says, what percentage of women are between 60 and 70 inches? So P being between 60 and 70. So I find 60 on here, I find 70 on here, and all I'm going to do is just add those all up, and it should be 99.7%. I did it a little bit faster because I knew that these were, nope, that should be 95%. I was just about to brag. I did that totally wrong. I shouldn't be speeding through it. Let's use Dora, make sure we don't mess up. So going from this line to this line, it should be 2 deviations away. I got kind of, I think because of how spread out my numbers are, 70% is right here. It should be 2 deviations away, so that should be 95%, which would be 13.5 plus 34 plus 34 plus 13.5. So 95%. And then finally, if a woman falls at the 97.5th percentile, which means at or below, that's what a percentile is, at or below. There's 97.5% of people are at or below her height. We want to know how tall she is. So she's a very tall person. If 97.5% are at or below her height, so she's going to be way, way, way over here, such that we only have, 2.5% on the right side. So all I'm going to do is either you can start from the bottom and just count up till you get 97.5, or you could start on the right side and count down for 2.5. So either we could go up 97.5% and stop there, or we could go down from the right 2.5%. Same thing. Either way, we end up at this 70 inches tall. That has 97.5% of the people below that height. She's a very tall person, so she's at the 97.5th percentile. All right, that should be about it. How do I stop this thing? Which is always a fun way to end a video.